Okay, we're going to do a little review of Algebra 1, looking at slopes of lines, writing equations of lines, and also determining parallel and perpendicular, which is the big idea in this unit. So let's begin with some basic formulas that hopefully again sound very familiar from Algebra 1. So slope formula. So given 2 points, x1, y1, and x2, y2, slope, remember, let me make that a little clearer, is represented with the letter m, and that's going to equal y2 minus y1 over x2 minus x1. So for example, if we're given 2 points like 1, 7, and 3, -2, the slope would be -2 minus 7 over 3 minus 1. And remember, you always want to reduce as much as you can, and feel free to leave it as a fraction. And that's probably the best way to leave it because we might want to graph it later. All right, two equations formats to write equations of lines. One is called point-slope form. So you're given slope, which is m, and any point, x1, y1, doesn't have to be the intercept or anything. We can write the equation as y minus y1 equals m times x minus x1. So this is your point slope form. So for example, if m equals 1/2 and you're looking at the point -3, 2, the point slope form would be y minus 2 equals 1/2 of x minus -3. And then you want to simplify that as much as you can. So y minus 2 equals 1/2 of x plus 3. All right. Point slope form is great because you can always use point slope form to find slope-intercept form. And what is slope-intercept form? So you need to be given slope, right, which is m, and the y-intercept, which is 0, comma b. So notice how the x has to be 0. Slope-intercept form is our very familiar y equals mx plus b. So again, slope, for example, 3 over 7, and your y-intercept, 0, comma, -2. We can rewrite this as the equation y equals 3 over 7x plus -2, or y equals 3/7 x minus 2. Okay, so let's remember those formats, and again, those can go onto your note cards for tests and all that, and take a look at example 1, A, B, C, and give it a shot, right? Try to remember what you know from Algebra 1, and try to write those equations. And remember, if you need to go back and pause to write this stuff down, feel free to do that. One thing I want to point out before you try this out, remember x-intercept, y-intercept are points. The x-intercept is the point here, x comma 0, so 2 comma 0, and the y-intercept would be the point 0 comma y, or 0 comma b. So just keep that in mind and give it a shot and see what we get. All right, so you can take a look at what I did here. Noticing you want to be careful with the directions. If it says point slope form, leave it in point slope form. If it's a slope intercept form, y equals mx plus b. Okay? One thing I'm going to point out for B, you might have realized 0, comma 4 is actually the y-intercept, but what I wanted to show you is you can always go from point slope form to slope-intercept form by simply distributing and then adding or subtracting. And that's something to keep in mind because you're not always going to be given 0, comma b. And you'll see that in your work. All right, graphing lines. So remember how to graph lines, you need 2 pieces of information, always. 2 points, a point, and a slope, right? So that's where point slope form and slope intercept form are both very useful. For number 1, you see this is slope intercept form. So what's the slope here? Well, slope is 3 over 2. What's the y-intercept? The y-intercept is the point 0, comma b. So that means we're going to start at the point 0, comma 3. So hopefully this is all very familiar, but you're going to start on the y-axis. Remember, the vertical is the y, the horizontal is the x. I'm going to go to 0, 1, 2, 3 to plot my first point. And then the slope tells you how to move, right? Rise over run. Up 3, right 2 because they're both positive. So I'm going to go 1, 2, 3, and then 1, 2, and there's my next point, right? So 1, 2, 3, 1, 2. Again, you can also go backwards, so I can go down 3, 1, 2, 3, and then left 2, and that'll still complete my line. So you'll want to use a straight edge, put an arrow on both ends, and we know that line never ends, and there's your line. Now with number 2, you have a couple options. You could either graph it using point slope form, or you can convert to slope-intercept form. So let me show you the point slope form first. So remember, m is in front of the parentheses, so here our m is -2, or -2 over 1. And then remember, it was y minus y1, so that's a minus -3, and then x minus x1, so that's a positive 1. So my point is going to be 1 comma -3. And in case that wasn't clear, let me actually rewrite that. How did I get this 1 comma -3? Because again, point slope form is y minus y1 equals m times x minus x1. So if I rewrite this using subtraction, y minus -3 equals -2 times x minus 1. So then here's my y1, x1. Okay, then you can go ahead and plot that. Again, x is on the horizontal, y is on the vertical, going to 1, then down to -3 for my first point. And then my slope is -2, positive 1. So when you go down 2, right 1. So down 1, 2, right 1, there's my point. And you don't have to draw these movements in, I'm just doing that to show you what I'm doing. So down 2, right 1, or opposite, up 2, left 1. And we're good. Now, if you don't remember point slope form, because I know a lot of people tell me they don't, you can always convert point slope form into slope intercept form. So, oh my gosh, sorry, I'm popping up all these things. So, if you wanted to convert to slope intercept form, remember all you have to do is distribute and add or subtract. So let's go back to that point slope form. Distribute, and then subtract 3. And you'll notice we're going to get the same line. So this one tells me I want to start at -2. Oh, I'm sorry, I messed up. Let's fix this here. So we want to start at -1 because I didn't distribute, so that's a positive 2. Minus 3 is -1. So I'm going to start at -1, and then I want to go down to right 1, right? Down to right 1. So that's the exact same line. All right. So just a little recap of that Algebra 1 there. And then let's talk about different pairs of lines. So we have 4 types of lines that I want you to be able to identify, either based on graphs or based on their equations. Parallel lines. Hopefully you all remember what parallel lines are. Parallel lines are, for example, y equals 3x minus 7, or y minus 2, and y minus 2 equals 3 times x plus 1. They have the same slope, different y-intercepts. And they never intersect. And that's important, okay? Perpendicular lines, for example, y equals 1/2 x minus 2, and y equals -2x plus 3. These are perpendicular lines. Why? Because their slopes multiply and create a product of -1. Meaning they have opposite reciprocal slopes. They are special because they intersect at 90-degree angles. Okay, intersecting lines are your plain old lines that intersect. So for example, something like y equals 5x minus 2 and y minus 3 equals 1/4 x plus 7. Nothing special, just different slopes. And they intersect at one point. All right. And then finally, coinciding lines. See if you can figure it out. They are, for example, y equals negative 3x plus 5 and y equals negative 3x plus 5. They are the exact same line. So same slope, same y-intercept. Because they are the same line. Okay, so you'll want to be able to use these pieces of information to figure out if lines are parallel, intersecting, coinciding, or perpendicular. So take a look at example 3, and I want you guys to take a couple minutes and give it a shot yourself first, right? If it helps, put your lines in slope-intercept form, right? So solve for y, and then double check their slopes, double check their y-intercepts, and then we'll check in a moment. All right, so take a look at what I did. So I showed you the work for solving for y. Just make sure you're dividing everything by the coefficient of y. Just a reminder there. So we have parallel, coinciding, intersecting, coinciding. Okay, final thing for today, writing equations for parallel and perpendicular lines. And I know this might have been something that you don't quite remember because it was a while ago. So let me remind you about what we need to do. Okay, so 4 simple steps. Number 1, determine the original slope. If you have m, awesome. If you need to find it using slope formula, do it. Then you want to determine the new slope. Are we going to keep it the same because it's parallel, or am I going to do the opposite reciprocal because it's perpendicular? So you want to look for the keywords in the directions. And then I always suggest plug it into point slope form. That way, if you do need to solve for y, it's super simple, right? Distribute, then add or subtract. Okay, so I'm going to do A, and then you can try B. So we want to find the equation of a line in slope-intercept form. So I know my final answer needs to be y equals mx plus b. That is perpendicular. So that means I want to do the opposite reciprocal to y equals 2x plus 3 and passes through 6, 7. So there's my x1, y1, and there is my m. So notice how I'm pulling that information. So my m1, which I'm going to call my original slope, is 2. And I want perpendicular, and the upside down t represents the sign for perpendicular. So when I think, what do I multiply to 2 to make it negative 1? What's the opposite reciprocal? Well, that's negative 1/2. And then I've got x1, y1, so let's go ahead and plug it into point slope form. So y minus 7 equals negative 1/2 x minus 6. Then I wanted y equals mx plus b, so I'm going to go ahead and distribute to get y minus 7 equals negative 1/2 x plus 3. And then add 7 to finish it off to get y equals 1/2 x plus 10. Okay? Nice and simple. Try B, and we are done. Oops, and of course what would be helpful is to know what point it goes through, so it's going to go through the point 5, negative 2. There you go. Now you can try that out. Okay, double check your work. So I actually had to solve for y to figure out my slope, which is 2. It's parallel, so I'm using the same slope, using that point I added in for you for x1, y1, point slope form, and then I want the answer in slope-intercept form, so distribute, subtract 2, and I got my answer. All right, so you'll be practicing this in class, and hopefully it's all starting to sound familiar. Okay.